Welcome, everybody. Welcome to this session on implementing a machine learning initiative. I'm going to provide some guidance for people who are in the leading position, managers. And as Turja mentioned in the chat, you might want to make your slides bigger. And to do that, just double click on the slides and it will make them larger. My name is Pogrebnyakov, and I'm a senior AI researcher at Thomson Reuters, where I work with natural language processing, mainly in the domain of legal text analytics. I'm also an associate professor of international business at Copenhagen Business School in Denmark. And there I work on technology strategy, strategy execution, international strategy in general. I'm also a creator of a course called Strategy Implementation on Coursera. And recently I also launched a platform called Leverness, which is an on-demand marketplace for machine learning expertise. If you're an expert in machine learning, you can register there. If you're looking for somebody to help you model or engineer a machine learning model, consulting, corporate training, you might want to go ahead and look for experts there as well. So based on my background, what I thought I'd do for this talk is I'm going to take some lessons that we learned from implementation of business strategies and business initiatives and try to apply them to machine learning and see how we can come up with some sort of a path for leaders, for managers to implement machine learning initiatives. And there are many things, if you think about it, there are many things that you as a leader can do to kind of the levers, if you will, you want to push to implement an initiative, a machine learning initiative. You might want to look at the need for machine learning. Do we need to apply machine learning to this problem in the first place? How am I going to lead this initiative? How am I going to measure it? What kinds of risks are involved? How do we prioritize and manage these risks? Some issues surrounding influence and power. How do we align machine learning with business strategy? What role does culture play? What culture do we want to institute in our unit or organization to help it implement a machine learning initiative? Communication, the organizational structure, where do we get data? How do we deal with resistance? How do we manage knowledge? There's just a lot of things to do. And we'll look at just a few of them. We'll look at just these 5 things. But keep in mind as we go through this talk that there's actually more things to keep in mind. These are, I think, the most important ones for leaders to consider. And by the way, it's customary, if you've ever been to a talk on implementation, on strategy implementation, it's pretty common to begin with the stats on how many initiatives fail because of poor implementation. I'm not going to do that, but these numbers typically go upwards of 50%. So initiatives that are planned are more than half of the time, they're not properly implemented. They're not successful. So I hope that with this talk, we'll get some insights on how to do things better so that we're not failing, but instead succeeding in implementation. So let's start with the need for machine learning. Do we need machine learning to address our task at all? And I know that this is probably heresy in a conference on machine learning operations to ask a question, do we need machine learning? But hey, why not? Some things are actually done better with other approaches, like a rules-based system or a human in the loop. And to figure out whether you need machine learning or not, you might want to look at 2 things. First of all, the external evaluation. Look at your industry. Look at your peers or competitors, if you wish, and take a look at what they're doing. The chart you see on the left shows the adoption of different kinds of machine learning technologies, computer vision, natural language processing, robotics, and so on. I'm just showing 2 examples here. This chart is taken from a report by the consultancy called McKinsey. But you see that in high tech and retail, even within these two industries, there's a great deal of variation on how companies adopt different technologies. So one thing to do when you figure out the need for machine learning is to ask, what are others in our industry, or what are comparable companies doing? The next thing to do is to take a look at your own company and understand the internal fit. And to understand this internal fit, it helps to ask two questions. First of all, can we specify the rules for whatever we're planning to do? Because some things can be formalized, and in this case, you might want to go for a rules-based system because, hey, you don't need labeled data for it to begin with. If you cannot specify the rules, you are probably going to go for a machine learning solution instead. Another question to ask is whether a non-machine learning system scales. Human decision makers don't scale cheaply or easily, and sometimes their decision making is not that consistent. Here's just a piece of stats on the same data presented to the same people within a matter of a few minutes or a few days. The rate of consistency of decisions is only 78%, which means that about 22% of the time, people make different decisions, the same people make different decisions based on the same data. So you might want to ask whether you want to go for a human decision making in this case. So I'm not going to dwell too much on this because we're in a conference in machine learning, but just keep in mind that sometimes machine learning might not be the answer. So let's say that you looked at this external fit, internal fit, and decided to go for machine learning. Now let's take a look at how do we align machine learning with business strategy. And to do that, it helps to start not with technology, not with the technological, not with the algorithms, not with the all of the things we actually saw in the external fit, but it helps to start with your own business need. And to do that, you might want to first ask some probing questions. And in response to these probing questions, you'll get some changes that will happen to your company, to the industry, to the economy. And based on that, identify opportunities for machine learning. I'm not going to go through all of these questions, but some examples are: what are competitors doing? What assumptions about our business are changing? What are the new expectations of our existing customers? Or what new customer segments can we go for in the next year? Well, when you ask these questions, you will be able to see where and when you can deploy machine learning. And at this point, I would like you to meet Jane. Jane is a senior data scientist. She was a senior data scientist in her previous role. And now she's hired as head of data science into a supermarket chain called SuperPrice. And specifically, she's focusing on home delivery. And SuperPrice is this large supermarket chain. Home delivery is about 5% of their grocery sales. They've been mostly using rules-based system so far, but now they're contemplating, they've done this external internal fit, and they're contemplating the need for machine learning. Actually, neither Jane nor SuperPrice exists. This picture of Jane was generated by a neural network, by GAN, and SuperPrice is also not it's also a fictional company, but I hope that they will help ground our further discussion. In the case of SuperPrice, let's look at one of these probing questions and see how it can apply this three-step questions, changes, opportunities for machine learning to their business. One question that they can ask is, what are the new expectations of our existing customers? And if you've been on this planet in the past couple of months, you probably noticed that home delivery of groceries is popular. So what they decided to do is they decided to revamp their existing rules-based system and introduce some machine learning into it. Now, one specific change that they're looking at is it turns out that although the share of online shopping is increasing, it turns out that online customers are not as profitable as in-store customers. There's a whole bunch of reasons for that, but that's just an observation that they made. And what they decided to do in order to address that is to launch a recommender system in their product search online. The customer comes in, types a product name, and in addition to the relevant product that are directly answering their query, they're also getting some suggestions from this recommender engine. The hope there is that this recommender system will increase the cross sales. In addition to, for example, apples, you'll also be selling some other products. And it will help raise the profitability of these online customers, which is one of our major concerns, or Jane's major concerns in this case. What we've done here is we've translated a strategic issue, namely the new expectations of our existing customers, into a machine learning problem. And as you go through this, you'll probably notice that it's not one question, one change, one opportunity for machine learning. It's more like a branching of a tree, of a decision tree. But the process here is simplified to give you some idea about how we go about this. Now that we went through identifying a business challenge, figuring out how to solve it with machine learning, it's also important to know for Jane how implementation is going. After she's going to start developing this recommender system, after she puts it in production, it's important to know how the implementation is going. And here again, what we'd like to do is to align our machine learning metrics with business objectives. Now, do you folks know the balanced scorecard? Well, actually, I can't see you, but I'm just going to assume that at least some of you have not nodded in agreement. A balanced scorecard is a way of translating strategy into objectives on specific dimensions. And you see these 4 dimensions here. We're actually going to repurpose the balanced scorecard, if you've seen it before, for machine learning. And what we're going to do is we're going to measure the success of our initiative on these 4 dimensions. Performance, which in this case we'll understand as model performance. The way you can measure it is with our familiar model metrics, such as the F1 score or accuracy. But there's more to that. You might also want to include the financial dimension in your assessment. For example, are we getting increased revenue, or are we cutting costs because we adopted this initiative? You might also want to look at the customer. What value are we creating with this initiative for the customer? And finally, the learning. These are competencies or technologies that you need to develop or adopt to be able to implement the initiative, or that your organization will get as a result of implementing this initiative. So let me just put this into more specific terms with our example of this recommender system in product search. In terms of performance, you are going to be looking at, again, machine learning metrics. In the recommender system case, these could be the top key metrics, such as the mean average precision at K, mean average recall at K, coverage, correlation. These are the familiar machine learning metrics that we all know and love. On the financial dimension, you might want to look at sales with this recommender system in place and sales without the recommender system in place. Remember, our goal here is to increase profitability of online customers. And the financial metrics, specifically this change in sales, will help us figure out if that's happening. On the customer dimension, you might want to look at customer satisfaction, however you want to define that. Maybe you're running a survey once in a while, or you might want to look at how often customers use these recommendations that are coming out of this recommender system. On the learning dimension, maybe Jane's unit needs to develop some new algorithms, or at least to explore what's the landscape of this recommender system algorithms. Another question that can be asked is, how do we deploy a trained model? All of these things, Jane's data scientists either don't know or they might not know very well and need to brush up on that. Just a couple of quick points about some selected practices in measurement. How do you go about measurement? First of all, you might want to use these metrics that we just mentioned for tracking, not as targets. Don't say my model is going to achieve 90% accuracy next month, but keep track of how your model is developing over time. Sort of set up a dashboard so that you see how your model is progressing. It also helps when non-technical managers are familiar with with machine learning metrics. You know, what's the difference between accuracy versus F1 or precision versus recall? That might be a tall order. So in this case, Jane, in her position as the head of data science, when she's in these meetings with non-technical managers, she might want to be sort of an interpreter and checking what these non-technical managers, how they understand the performance of the model, for example, and making sure that things like whenever a data scientist comes in and says, you know, I got 95% accuracy, by the way, my data is 97% negative class, she'll be able to sort of guide the discussion in the appropriate resolution, avenue for resolution. By the way, many of non-technical managers are well-versed in statistics, and machine learning has fewer assumptions about testing, about modeling than statistics. And in my experience, people with background in statistics tend to transplant, so to speak, these statistical assumptions into machine learning. And they start asking questions that might not always make sense from a data scientist perspective. But I think of it as actually a good thing, because because these folks understand that assumptions exist, and it's just a matter of explaining that, well, in machine learning, the assumptions are a little bit different. It also helps to establish a baseline, compare your model's performance to whatever baseline you might want to set, either manual performance, a rules-based approach, a quick and simple model that you can implement linear regression, XGBoost. In different cases, this simple model is going to be different. And finally, think how are you going to account for model drift on all of these 4 measures. I think we're pretty accustomed to monitoring drift in terms of model performance, but I think it's a pretty narrow formulation, because you might want to also account for financial performance, how that develops, what's the customer satisfaction or the use of these recommendations, in our case, by the customer, how that develops over time, whether our approach on learning dimension, our approach is no longer state of the art, or maybe there are different approaches that we can try to boost model performance. So that's another thing you might want to keep in mind. The next stop or the next lever in implementation is going to be culture. And culture, I'm just going to put up this definition that culture is values, the core values, beliefs, and traditions within the organization or a subunit. And what it means is, for machine learning specifically, there are a few cultural traits that you might find helpful. Helpful in the sense that they're going to make implementation easier. One of them is learning. And we know that machine learning moves fast. And let's imagine a hypothetical scenario where Jane has 2 data scientists working in her unit, Steve and Amy. Neither Steve and Amy exist, by the way, just as Jane. But Steve and Amy are both working on a model. And their model, in both cases, hits 80% performance. What does the data scientist do at this point? Well, they try to implement all of the techniques they know to improve this performance. Maybe try some hyperparameter tuning or feature normalization, what have you. And Steve does that. Steve does everything he knows. He applies all of these things he knows. It's still 80%. Steve goes back to Jane and says, you know what, I'm done. It's 80%, I did everything I could. What Amy does is she sees this 80% performance and she goes to Google Scholar or she reads a few blog posts, and there she picks up another algorithm or a different feature representation that she tries on her model. Then she goes back to Jane and says, you know what, I'm done. It's 85% performance. I did everything I could. So this is learning as a cultural trait in pretty specific terms that one of these data scientists, Steve, is not very amenable to learning, whereas Amy is. Another trait is, helpful cultural trait is positive attitude to risks, acceptance of mistakes. One way of promoting this could be sharing work in progress within your team. And the way to shape culture, how does Jane go about shaping this culture? One obvious thing is to assess candidates for positions in her unit, also on cultural fit, but also look into things like stories, organizational stories that help explain culture and propagate it. One example from Google is when, back in the early 2000s, the paid search results, as opposed to organic search results, were not very relevant. And what Larry Page, I think, back in the days did was he printed out these irrelevant paid search results, circled them, posted them on the bulletin board in the cafeteria, and 3 days later, somebody, a group of scientists at Google, emails him a solution, a proposed solution for that. So this is a kind of a story that tells you how things are done in the organization. And it turns out that there are not many different types of stories. According to one research, there's just actually 7 types of different stories. One of them is, how will the boss react to mistakes? Another one you can say is, from this Google example, is how do employees organize themselves. Bottom line is, you might want to actively look for, as a leader, for these stories and tell them to people who already work in your organization and also to new recruits. And finally, you might want to go for other units in your organization and take a look at what cultures they have, and maybe their cultures are going to be helpful for you as a leader to implement machine learning. You probably are not going to find too many risk takers in the accounting department, but maybe the logistics department has a data science unit, or maybe the same logistics department is experimenting with things and is very tolerant of mistakes, as we said. For example, in response to this COVID pandemic, Carrefour, which is a big French supermarket chain, they increased their stock of essential items from 30 days to 90 days. So all of this experimentation can be helpful for you to rely on. And one last point I wanted to pay attention to in implementation is influence and power. Why is power important? Because you need help of other people and other departments in implementing your initiative. You're probably never going to find yourself in a situation where your department is self-contained and you can do everything by yourself. You might want to need some data from people, processing power, knowledge. As a newcomer to this industry, to the grocery industry, Jane might need some help in figuring out how things are done. So there are many things that we can ask others for. And we often think of power as formal power, meaning that I have a title, I'm here in this organizational chart, and this is my power. But if you think about it, first of all, this newly formed department of data science within home delivery in SuperPrice is not going to have too much power because it's newly formed. It's pretty small. Here, you see this 5% figure. That's the basically the online delivery share of all grocery sales. 5% is small. They often lack power. So what you want to do instead of relying on formal power is go for informal influence. And a more complicated way of saying this is to look for interdependencies outside of your chain of command, which means that one thing you can do is to ally with more powerful units. In every organization, you will see that there are some units, some are less powerful. For example, in research-intensive companies such as pharmaceuticals, the R&D unit is very powerful. They have bigger budgets. They get listened to a lot. In highly competitive industries such as automotive, car manufacturing, you have the marketing department that's pretty powerful. So it's just a matter of going and finding these units. What you can bring to these units is typically your machine learning competencies, because even though you're newly formed, you can turn this into your advantage and say that we are not burdened by the legacy of the past. We're experimenting with new approaches, or maybe these other units haven't tried machine learning at all. Build informal networks, and maybe identify some influential people that you can rely on. So maybe for the recommender system example that I gave, it would be helpful probably to get some data from the loyalty program. So either go to the head of this program yourself or find an intermediary that can help you get there. To conclude, what Jane can do, and again, we're looking at a very small subset of all the levers that are available to you for implementation. But what Jane can do is, first of all, identify the need for machine learning. We said that this comes from external evaluation and internal fit. Once the decision to go for machine learning has been made, look at the alignment between your strategy and machine learning. It helps to ask strategic questions, and from there you will trickle down to the opportunities for machine learning. The measures that you might want to put in place to track progress, and we said that it's not just machine learning performance, machine learning model performance, but also things like financial metrics and customer and learning. And two levers that can help you get things done is culture. You might want to cultivate good, helpful cultural traits in your unit. And in terms of power and influence, it helps to go beyond formal power and examine ways in which you can gain informal influence or gain an alliance with somebody who has power. So this is it. Thank you. And now I'm going to be taking questions, folks. If you have questions, please post them in the chat, and I'm going to go through them. I also am aware that the session is going to end in about 2 minutes. So if you folks need to leave, then please go ahead and do that. But if you can, just stick around and let's see what kind of questions we get. Let me just see. Okay. Okay, I'm just going to start from the beginning. There's a question from Heathcliff, and I apologize if I mispronounce any names. There's a question from Heathcliff. In your example for Jane and her decision to choose an ML model, is there a decision tree to use to choose which solution is a good fit? Why recommender was chosen? That's a great question. How do you decide which technology to go with? I think you need two components here. Again, you need a business you need somebody who understands the business challenge, and you need somebody who understands data science. And I put Jane there on the spot because she's a data scientist who is now put in this position of making business-oriented decisions. When you have this background in data science and somebody comes into you and says, here's what we need to do, you probably already have some lights, some some bulbs popping up in your mind on how we're going to address this challenge. How can we solve this problem with machine learning? So I'm going to be hesitant to say that there's an algorithm you can follow, but my suggestion would be just to put a business person and a data scientist in the same room and let them figure it out. Amir is writing, in aligning machine learning metrics with business objectives, in your professional experience, how do you approach getting business to define what is considered success and then getting them to stick with it for the most part? That's an excellent question. What is considered success can be pretty hard to define in advance. And for this reason, you see this interest in agile everything these days. You don't basically just put a goal, which is 1 year or 2 years in front of you. You might want to say, here's where we're going to strive to go. And but you allow some room for adjustment on your path. It really depends on what you're actually doing. If you're building a new product from scratch, you know where you want to go, right? You have to do this market analysis. You have to go through all of this exercise. But even with that careful mapping of the landscape, you might find 2 months down the road that your assumptions were not relevant or valid, and you need to pivot a little bit. If you are doing something internal in an organization, I would say there's more tolerance for this pivoting, and you have to be careful to communicate that. Things change. I'm not talking about machine learning change, but I'm talking about this alignment between machine learning and strategy. Things change from this point of view and also from the business perspective. You know, we were in a completely different world 4 months ago. I think it's a pretty tired point by now, but it's true. I mean, things happen. Things do change pretty frequently. This was true in 2019 and 2018. Just today, we're just seeing a faster pace of change. So it's what I would advise is to instill this sense of agility to your approach and make sure that you're genuinely striving to achieving some objectives. But if you see that the market is not going there, or the solution is not working as you want it to work, this is why I'm advocating the use of these different metrics to track your progress. If you're seeing that something's not working, you might want to change. And how do you get the business to stick with it for the most part? That's, again, sometimes this can be a piece of advice that's probably not that relevant, because you might want to have people, the business folks, understand that things change, and they do understand that. It's just the added complexity, if you wish, of bringing machine learning and experimentation here. I hope I answered your question. I know this was a long answer. Trevor, if you suggest not having metrics as goals, what would be an appropriate alternative to increase accuracy by 10%? The reason why I'm advocating not using metrics as goals is because it's, I mean, you can have metrics as goals in many functions. For example, in sales, you can tell a salesperson that your quota for going out and making contacts with potential customers is 10 per week. You have to go and make 10 contacts with customers every week. We're not going to measure on how many new customers you're bringing in. We're just going to measure you on how many customers you go out and reach out to. So you have to be very careful with metrics, because when you start measuring things, you will see all kinds of behaviors that you might not have anticipated. And in the case of machine learning, it's plain hard to predict how your model is going to behave in a month, because if you knew how to get 10% boost in your model, you probably would do it by now. So an alternative to that is, again, to track progress and show to the business that, hey, we were here last month, now we're here. Look at this differential in performance. We're not going to promise that next month we're going to be here, but you see how much progress we've made. So I think this kind of looking backwards helps in terms of explaining where you're going. And as David said, that goal might get you in trouble. Imtiaz, can you explain further on how statistical assumptions are different from machine learning? I'm not going to go too deep into that, but what I meant was that if you look at any statistical test or modeling technique, you will see that, like, if you just take plain linear regression, you will see that there's a whole bunch of assumptions regarding multicollinearity, the normative distribution of your data that have to be fulfilled. And many statistical methods come loaded with these assumptions. For whatever reason, maybe the data sizes are larger, data set sizes are larger. For whatever reason, machine learning is not that laden with assumptions. So I hope that answers your question. Amber, when machine learning is first introduced to a specific area of the business, what's a good baseline model to report model performance? The easiest thing you can do, if you already have something in place, if this function is already, if this, whatever you're trying to put machine learning to work for, is already done by something, spam filtering done by humans, or, this is a, probably a stupid example, but to drive the point, or, basically, if your task is already done by something, this could be your baseline. And this is when you'll be able to say, look, we were here last month with our rules-based system or human performance. Now we implemented machine learning. Look where we are. If this is not the case, if you don't have this natural baseline, so to speak, then come up with something quick, very quick. The easiest thing you can think about. Again, it could be logistic regression or XGBoost. It's going to be different in every case, but don't spend too much time on it. Just spend a few hours, and this is going to be your baseline, and you're going to measure your progress relative to this baseline. Arash, which industries have you encountered that, in your opinion, would benefit the least from machine learning, relatively speaking? I think it's not the question of the benefit from machine learning as such as to what extent the industry is ready for this. There are many industries where machine learning has not worked 5 years ago, but it's the craze right now. And the reasons are multitude, because of availability of data, again, because of this herding effect that I mentioned, when companies start looking around them and see, oh, our competitors are doing that, or people we know in other related industries are doing that. Let's try it ourselves. So I wouldn't say that it's the question of benefit per se, but it's a question of timing, and to what extent it's a good time to start adding machine learning capabilities to a particular industry right now. I would say that it probably comes down to two things. First, the availability of data. Just to give you an example from manufacturing, with all the sensors and the Internet of Things that is being put in place right now, you're seeing the actual need to analyze all this data, which wasn't there 10 years ago, maybe. Whether machine learning can be applied to construction, are they capturing the similar amount of data? I don't know, but I think but they might in a few years' time. You already see actually a lot of movement in the construction industry. So it's probably a question of timing as to where the crest of the wave of machine learning is right now relative to different industries. So thank you, Rush. Paula, thank you. Kamal, do you have any advice for managing the expectations for machine learning teams? Sometimes machine learning is seen as magic and solution to everything, and this can result in disappointment from management. Excellent question, Kamal. I think the answer to this is manage expectations of the business. There's a lot of hype surrounding machine learning and AI right now. And people who are not in this field can get crazy ideas about what machine learning can do. And I think it helps just to maybe, in simple terms, in really simple terms, explain to them what can you expect, how it works, that it's not a silver bullet, but basically what you do is you just take some data, and if you, the business, have data, show it to us. If it's clean data, if it's good data, we can use it. If it's not good data, you can't ask too much of us until we get more data. So it's just walking them through, explaining what machine learning is, and I think this would help a lot in addressing this anxiety surrounding machine learning. Kind of shine the light a little bit on show the kitchen on what's going on. Okay, Imtiaz, how can leaders with limited experience in ML qualify validated claims by others? For example, hiring, agreeing budgets, and so on. What's the route to finding honest Janes? I think it makes sense. I don't think that any manager would be deliberately misleading, and I think we as folks who do machine learning, we have this responsibility, as I also mentioned in the answer to Kamal, of explaining how things are done. You don't want to explain the intricacies of the algorithms, but either just make managers understand. And I've seen, managers who come into these meetings with data scientists and they start asking questions. Well, how come this model performance is 60% or 70%? Why it's not 100%? And in a couple of months' time, after these periodic meetings, you see explanations, maybe showing a little bit of the work that has been done in these couple of months. You see more understanding from the business for why, and appreciation really why the number is where it is. So I think it's a matter of education on our part, on the part of people who do machine learning. Okay, I'm just going to take 2 more questions, and one question comes from Lana, because this is the end of the feed right now. What is the best organizational structure for a machine learning product in terms of technical leadership? Should data scientists overlooking business research and implementation MLOps? The challenge we're facing as data scientists is relatively junior in DevOps domain, but engineer with more experience facing a learning curve. Well, in terms of, if I understand your question correctly, then in terms of how do you structure your team, it probably helps. I mean, there's a tendency these days to make things as flat as possible, and then have not that many levels of formal hierarchy, but have people at the same level sort of coalesce in self-organizing teams. And there's a lot of stuff out there about how to manage these self-organizing teams, how to facilitate their creation. And I think in your case, what you're asking is you have a data scientist and a DevOps engineer. You might want to facilitate their mutual work. And in terms of who, so this is going to be in terms of how you structure that, and in terms of who you're going to put as the responsible person for that effort. It really depends. You know, you can put somebody even with a business background, but then make sure that they interact very closely with data scientists, or you can put either of these two folks, data scientist or engineer, but you also have to make sure that they understand the other side. So I hope I answered your question here. And the question from Tapadipta: I'm currently working as a functional leader between scientists, engineering, and business. I have to manage expectations every day. Thank you, Tapadipta. The question is, how do you influence leaders to get more labeled data in terms of annotation cost? Well, one way, which is pretty blunt, and I've seen this happening, is to show them poor model performance and say, look, you business come in with these roadie expectations, and you expect that machine learning is going to solve everything. And you give us a budget of this much for annotating data, and look what we got. And you can actually make a plot, even with this much data. You can show them that with this much data, if you just take a fraction of the data set, you get this much performance, and with the full data set, you get this much performance. And you're not going to promise that with more data, the performance is going to go even higher, but you can say that here is the progression. And I think it again goes to the point of education, because you know, it's not a free thing, right? And that's why I said in the beginning that sometimes rules-based systems work reasonably well at a lower cost. So it's kind of, again, I think it goes back to how you manage the expectations of the business and show them a little bit of the process of how it works. Okay, thank you very much, folks. I really appreciate the questions, and I hope you enjoy the rest of the conference. Thank you so much. Take care.